We do have some other things that we're trying to chase, Barnett being one of them up there. It's a bit unproven on the platform, but there are places where it might work. So this area represents a different type of play, being a northern extension of an existing Barnett play, that if it looks good, we need to be able to present to them the evidence such that they may allow us to go start a leasing program. So that's where we are. So after looking at all the data, what are your thoughts?
Okay. Well, let's have one of my staff go ahead and put up the slides that we've got prepared, and I'll let them talk to that. Just as an opening here, if people aren't exactly oriented with all these weird names and people on the call here, I've got 3 folks that work for PetroRes on our team here. Pond and Ploy, Chaya Newt is Ploy, and Pimpicon is Pond. And then I've got Tevedet there, who's a new petroleum engineer that just joined us as an intern this week. So baptism by fire.
Hello.
Yeah, he wants to learn petrophysics. So
awesome. Well, welcome. Good to meet you.
So Pond and Ploy have put together. We worked here on some slides for you to detail, what you sent across. We basically, peeled it, skinned it, boiled it down, figured out what's in there in terms of data quality, coverage, things like that. To your other comments, you've got kind of a science experiment here to some extent, right? In identifying what exactly it was that these high production wells hit in terms of the target. In order to kind of zero in on that, we're going to need sufficient data over that interval in that area from some of these wells to get eyes on it, right? And I think my quick glance at the data at this point, which I've not gone through it in any detail, I've just kind of flipped through the wells, if you will. And the girls here are going to show you the details, but it looks like it's sort of a 50-50 thing, right? Like half of it's good, half of it's bad. In terms of fixing the bad stuff, like we can do a lot of things, but at the end of the day, you're sort of making data up. So it just depends on your comfort level there, and it depends on, how much we're making up, right? Is it sort of a thing where I can give you a 90% answer, or I can give you a 60% answer? Are you going to live with that or not? Especially when you're making decisions here, trying to get capital and stuff like that. You probably you may want to leverage the higher quality data rather than try to fill out a data set with poor quality data, right?
Right.
But if you would, Ploy, Pond, please show Eric all the great work that you've done here going through this data set.
Okay, Pond, let you share our screen. Okay, hi everyone again. Today we will walk you guys through the Pioneer projects. Focusing on the data quality review. So for the first one, from all of the data we have, there are 52 wells in total. As you see at the green dot on the map, the well that we can actually use for the interpretation, and the red dot are the ones we can't use because they are missing key curve like resistivity. And next, and from the usable data, we have 11 wells are good quality and 22 wells are poor quality. Also in the platform area at the bottom, as you see, there are 2 wells with the TCMR logs.
So let me just stop really quick right here too. We've got this convention, right, that we label these wells like a G7 or a G3. It's
yes.
Basically just to flag it that, we've got full quad combo data over the interval, right? Sonic, neutron density, all the good stuff. A G3 is a triple combo, so everything minus sonic. And then these G1s are wells that, you know what it's like. Railroad Commission, operator submits logs, they leave out resistivity, give you micro log, right? So you've got everything you need with a micro log, and that doesn't get you saturations. Um, the coverage there you can see on the map kind of, there's a few good green dots in the northeastern side of Andrews County where you're prospecting, right? But as you go north, there's a gap there. So, and then unfortunately, we always like to have high quality logs and stuff to calibrate our models with, and the only two logs that have NMR total porosity to do that with are up on the platform. So,
Yes.
not going to be the same facies, right?
Right. Yeah, right.
Go ahead and continue. Sorry about that.
Thank you, Ryan. Okay, this slide show the Barnett isopath map. Represent thickness variation based on your top. The yellow dot is the Texaco well. From the map, there are slightly thicker tend toward to the southwest, as you see. It seems like a small trough feature, but overall the thickness across the well is quite consistent. Next is here's an overview multi-well cross section. As you see, the orange shading it show area with minimum washout in the Barnett. Yeah, is the caliper curve and B shade with the orange. Okay, and next.
So if you just go back to that cross section really quick. So the idea here is just to kind of illustrate, what good quality data looks like across the Barnett. And actually, up here in this part of the basin, it's not as bad as it is obviously in the south, right? Like that stuff down there with the Chester Shale and everything, highly reactive with water-based drilling fluids, just blows out and there's nothing left. This actually isn't too badly behaved. So what Floyd did here, she put together this cross-section plot with like a gamma ray curve, and then the next track is a caliper and a D-row curve. So the caliper is shaded with that orange. It shows you where the enlarged wellbore sections are, and the thing's flattened on the mist lime pick that you made. So, the base of the Barnett. So, some of the wells not too bad. It seems like the basal part of that Barnett is the one that's kind of washing out in most of the wells. I don't know what's going on there. It's got the highest gamma ray. I just assume it's a lot of clay or something, right? Low resistivity. But overall, right, these aren't bad. There should be, sufficient amount of data to be able to clean it up properly and give you a reasonably accurate answer, versus other areas where we've worked Barnett projects where the hole is gone, right? So if you've got nothing to work with.
Yeah. Okay.
Yeah, and the next, for the bad data, most will show washout in the target interval, as you see in the circle red. So we need to edit the data like a depth shift or other words edit, which make the result more reliable. And next, here's a quad combo plot comparing the good and wells and poor wells. Sorry, as you can see in the target interval, the best well in the right hand side have a washout, and the low B is look off from what it should be, as you can see. And
that's sort of a nice comparison there, of what the differences can range here across your data set, right? Stuff on the left is kind of what it's supposed to look like, minus that washed out section at the base of the Barnett, and then on the right is sort of the typical, Permian Basin Barnett log that we get. Or even if you look at the resistivity data, right, it changes quite a bit because there's so much material removed that even the resistivity tool is affected by that.
Yep.
Yes. Okay. This is a T combo, compare good versus bad. For the T combo wells, we can synthesize the sonic using ML, which is a proven and reliable method. This helps us still get a high quality for the interpretation, even when the original data is poor.
Okay.
So what about missing data well? Some of the well are missing critical data like resistivity. So the question is, what do we want to do with this? I want to say ML can help fill some gap, but do we really want to generate something like resistivity? I think it's a bit risky. And so there are only so much we can do. In some case, we may just deliver some of the results, like total velocity, only if the resistivity is missing. So we can also try a moonshot using the neutron and gamma ray, but to be honest, expectation should be low.
Okay.
For all the data we have, most of the data using have induction resistivity logs show in the dark color in this map, and only a few will have lateral log resistivity, which you can see in the light brighter color here. So for the best well to use for calibration are wells 34 and 36. So they are high quality wells in good condition with no washout and no synthetic data.
So if you just want to go back really quick to that table on, so we'll provide this to you, right? They've gone through and created a comprehensive sort of inventory and categorized all of the data that was sent across, so you can use this to supplement what you got, I guess, and figure out what you want to do.
I think we have that table. Where are those two wells located? Again, can you show me the map? Where are those two wells located that you have the red box around?
38 and 39, wells number 34 and 36. You probably have to back up to the map at right there, maybe. I don't think they're on the platform, so, well, one of them is, isn't it? The 36 is up there. But the other one's probably somewhere in your, I guess, that university land stuff that's in Eastern Andrews, Western Martin County.
Mm-hmm. Yeah. Yeah, there are a lot of university wells in there. UL lands are right there. Okay.
Okay. So we use our app to check the lobby and NV statics, and it highlight a few wells here that stand out and calibration because they show strong washout that interval in this interval.
So this is sort of a neat way of looking at the data, right? What they did is they created some heat maps where the formations are running across there and the wells are in the columns, right? All these different wells. So it's a real easy visual to just look at average values of different input curves and kind of pick out the outliers, right? What's bright, what's dark, what's going on. And you can see, like, in the limestones, the neutrons are low, and in the shales, the neutrons are high, and, vice versa with the bulk density. So I thought this was a pretty cool plot.
Yeah. Interesting, yeah.
So here the box plot show the you can see caliper here. This value clearly show heavy washout here. And here's an heat map across the well of washout in Burnett interval. Sorry. Yeah, you can see heat map here. Oh,
Yeah, my apologies
Yeah.
for that one. I sort of drew that in there. That white line, if you go back to that, with the white line, that's just to sort of orient your eye, right? Because like the software that I wrote is not the best, and it doesn't line these things up or flatten. So just to kind of show you where the barnets are, but basically wherever there's a white line and there's bright colors, it's washed out. If there's a white line and dark colors, it's a good quality log, right?
Okay.
So total data inventory from, not any particular cross-section line or anything going through that, but like I said, it's a 50-50 mix. You can kind of see it there, right? Between dark and bright.
Yeah, okay.
So from all of the 52 wells, they have 33 are usable for interpretation, and the well that don't have key curves like resistivity can really be used. At the same time, synthetic curves are a bit risky because it's come with quite a few limitations. So for the next step is to design which wells to focus on and which intervals to analyze. And for the well, we can either wait for more data to build a better calibrate model.
Good.
I'll move ahead now using our best estimate.
Ryan, could you put together just a ballpark estimate if you were to use all of the usable wells that you have at your disposal, use all of those, do the corrections, whatever else you need to do to those, and see what we could get out of that? Could you come up with an estimate of cost for that so we can take that forward and discuss it internally, with those 33 wells, and then we can take it from there. We have, as I mentioned early on, we have some other things that we're showing our capital guys, and we will need to kind of throw this in the mix and see where it might fall on our priority list to take this forward. And if we have enough evidence or information to indicate this could be something that we would want to do, we'll need to see where and when we may want to toss this into our rankings of our projects that we currently have underway.
Okay. Yeah, this is a bit of an odd one in terms of kind of putting together a cost proposal, because I assume that, it's just that Barnett Miss Slime sort of interval that you're interested in, right?
Yeah,
so
it is.
Yeah, so if we just, focus on that instead of doing a whole well analysis, which is, the sort of the standard approach, it's significantly less footage, right? But at the same time, there's going to be a lot of data manipulation, and that needs to be done very carefully as well. And, we've got a lot of experience doing that sort of stuff. So what I'll do is I'll put together a quote and send it across that sort of makes sense in the fact that, we'd be looking at something like 1,000 to 1,500 feet of interval per well. And then obviously, if we just work with the better quality data, it's a lot less hours than if we're trying to take some of like the old neutron logs and gamma ray stuff and, invent all the other logs from that, which again comes with a lot of problems, and you probably don't want to do it. So,
well, right, and we may want to just pare this down to some of the, the better quality wells that don't require a ton of manipulation, and see what that may tell us. Maybe that's the way to do it, and you can tell us if maybe we do that first and see what it tells us, and then if we need to, we toss in some additional information. But maybe we could, if you think it's advisable, the best quality logs looks like 7 there, that you would call the top tier logs that kind of seem to be in the area where we're looking that's near that Texaco well. Would it be reasonable to assume we could start with those 7 and see what that tells us, and then if we need to go forward, we could add additional data? What do you think about that?
That's probably a pretty pragmatic approach to take, I would guess, right? Start with the highest quality data set, and that's going to build your model, right?
Yeah, let's do that then. Let's start with the best quality logs. Those look to be, in the area that we're interested in, and around that Texaco well that was the good producer, and let's see what that tells us. And then if it requires some additional analysis, maybe throw a few more wells in there. So let's just start with that estimate and see what that looks like, and then maybe move forward from there.
Okay. I'll put something together here and get it to you shortly.
Okay.
I've got one comment I'd like to add. I think we need to also include in that initial look is the 2 wells to the south in southern Andrews County, because they are on the platform. They're considered part of the Barnett play. And how are they different from the wells to the north where we have our area of interest?
Okay. Toss those in too, Ryan.
Yeah, and that'll be a really easy one with the calibration data down there, I think, to give you an idea. I'm just round out that data set, like you said, right? Give you an endpoint to look at so that you know what the other side of the coin looks like.
Yeah. Okay.
Perfect.
Anybody else out there in the opinion side have any comments or questions before we shut this down?
I have one additional comment. Ryan, do you want to see a map that shows in the area of interest where all of the wells are that had oil shows from drill stem tests, whole core, that kind of thing? Because we have that. We can send you that map to show, why we're interested in this area. It's not just those 3 wells that produced. There's more evidence than that.
Number of wells that had really good oil shows, good drill stem tests from that Barnett interval in that general area. So why don't we just go ahead and send that to you just so you can see for context what we're looking at and why this attracted our attention. We'll go ahead and fire that off to you as well.
Yeah, absolutely. I'm never going to turn down data, right? Like the more we learn, the more we know, the better we get. So absolutely.
Right. Okay, perfect. We'll send you that. And if there is something any questions that you have while you're, working up that estimate, we may have something else that could help. So if you have any requests, let us know. We could just say, yes, we have it, or no, we don't. And let's just see what that looks like. And I heard Rand say that it sounded like a good idea. Thomas, I did not catch your comment. What was that?
Yeah, I was just saying, appreciate the work on all this. This is interesting to see.
Yeah, it's interesting. We appreciate the work that you guys have done so far on this. Thanks for that slide deck. That was very informative. So thanks for putting that together. And Ryan, we will be around. So just send whatever on to us whenever you have it ready, and we'll discuss internally.
Sounds good. Appreciate your time, everyone.
Yeah. Thank you, everyone.
Thank you very much.
Thank you.
We'll be talking soon.
All right. Take care.